Hello guys, welcome to my YouTube channel. Today we are going to continue with the development of this full course, specifically filling the form of all information required in an HVAC project. And on this form, I added the type of gas on the system part. So it is important also to identify which type of gas you are going to use on your system. And this selection that depends on your supplier and also what do you have available in your city, because you want to select something that will be available in your on your workplace, because if you have to mm, perform any maintenance routine, it is important to find everything locally, and because this way will be cheaper, and also this refrigerant is less aggressive to the environment. So you probably will find this refrigerant in another equipment. Okay, today we are going to develop the space part. So we are going to start with the space usage. Space usage basically will tell us what is the activity that we are going to perform on the space. So basically, we have on the guardhouse, we have the reception and we have office spaces. So we are going to assume that everything will be used as an office, because you have computers here, you have people working here, you have desks. So basically, it will be an office. So let's mark the office option, and let's continue with the floor area. Also, you can have gyms, you can have restaurants, you can have theaters. Depends on the project you have. So in this case, we marked office floor area. Sorry, floor area is related to the surface of all structure. You can calculate it. You have two ways to calculate this area. The first one is using the dimensions that you have here on the drawing, or measuring with a scale. If you have, for example, a circle, a rectangle, or a these type of forms are easier to calculate. But in this case, we have a different form, and using just the scales and the dimension won't be enough. So I just recommend you, when you have this type of shapes of in your structure, use AutoCAD. AutoCAD will be more accurate and will give you the number you need. So in this case, we need the AutoCAD drawing. We're going to develop this drawing on AutoCAD. So far we're going to leave this space in blank. We're not going to fill in this information until we finish the AutoCAD drawing. Ceiling height, well, ceiling height will be 9 feet. When I'm talking about, when I say ceiling height, I'm talking about the conditioned space. Let me show you. Is this space that is below the ceiling? This is the space that we are going to take in count for our design. So is the height from the ceiling, the landing ceiling, to the floor. So we have 9 feet. Structure, structure weight. Well, what is important to know the structure weight of our structure, because that will tell us how the heat is converted into loads in the spaces. For example, heavy buildings tend to absorb and store heat for longer periods than that light building. So this information will give us an idea how heat behaves in our system based on the materials. So in this case, our structure is a light building. It's in a small space, and the materials are not too heavy. And this information, um, you can get it. You can get it from your drawings or from your clients. If you don't have if you don't have the weight, you can calculate it. You can calculate it by using the weight of outside walls, partitions, floor, ceiling, structural members, supports, divided by the air conditioning floor area. So what you have to do is to identify all the materials and divide that information, divide that weight by the floor area. So in this case, the information I received from the client is that our structure is a lightweight lining fixture. Which type of lining we have? Resist vented, spring hanging. So let's take a look what we're talking about. In this case, we have suspended but pending surface mount resist vented, and we're not going to use this one. So when you say resist vented, it's referring to air is coming out or was getting to the light. This sometimes happen in a executive offices where the client wants to save devices and have everything just in one thing. In this case, when you use a resist vented lining, is because you will have the air supplier, and the lining on the same device. So that will allow you to save more space, and also you won't have like diffusers or grills all over the place. It's not really efficient this way, so in this case we are not going to use resist vented device. We're going to use resist and suspended. No, just resist, sorry. Resist unvented is our type of structure for the lining fixture. Lightning wattage, we're going to use, when you are need to input this data, you have two ways. You can use the wattage that comes from on the submittal of a lining, or you can use what the standard says about, depends on the usage and depends on the area. So for example, we can check this table from the ASHRAE. So we have here basically lining power density using space by space method. We have almost all the usage for the structures, hospitals, we have gymnasium, we have hotel, we have different things. In this case, we have office, and we have enclosed office, and we have open office. So if we take a look of our project, we have an open office here and another open office here. We don't have enclosed office. So in this case, we are going to select open plan and 0.98. 0.98 will be our wattage for lining. Ballast multiplier. Okay, in this section, we need to select which type of light do we have in our system. Do we have incandescent light or fluorescent light? If we have incandescent light, we have to select the ballast multiplier 1. If we have fluorescent light, we we need to select the ballast multiplier 1.5 because fluorescent light generate 25% more of heat than the incandescent light due to the ballast multiplier. Here on the form, I'll leave in this type of images just in case you want to check the information that I'm giving you. For example, fluorescent light wattage is multiplied by 1.5 to include heat gain ballast, is what I'm telling you. Also, you have information about what I'm telling you, and this type of lining generate much heat. So in this case, we are going to select 1.5. Lining schedule will, again, that is an information that you have to get from your client. You need to get when do you want to switch on all the lights and when do you want to switch it off. In this case, he told us from 6 a.m. to 7 p.m. will be the lining schedule. Task linings, we don't have task lining here in this project. Basic task lining are this type of desk lining to help us to perform a specific activity, like if you are checking a drawing or something like that. But in this case, we don't have task lining. Electrical equipment, wattage. So this is an information that you have to get from your electrical client or your electrical engineer, because they have to give you the list of all equipment that you will have there. It is important to have the list of all equipment you will have there, or at least the total number of the wattage. For example, you have here like how many you have, like 8 computers, you have microwaves, you have this machine X-ray detector. So you need to have that information. So in this case, we get this number, 15,110 wattage is our number. So let's continue with the electrical equipment schedule. Well, basically will be the same as the worker schedule. The worker schedule will be from 7 to 5 p.m. and I mean, you can ask to your client if he wants you to make your calculation based on this number. In this case, we're going to use the same schedule because the computer is supposed to be on during this period. So let's take the electrical equipment schedule the same as the worker schedule. Numbers of people, you need to know how many people will be working there. In this case, 10. Activity levels is, I mean, how much movement it will be in that project. I mean, will be an office work, will be a sedentary work, medium work, heavy work. In this case, will be an office work. Work schedule, well, we said this array is from 7 to 5 p.m. Miscellaneous loads. Well, in this case, it's really important to know the miscellaneous loads. When you're calculating a thermal loads, basically what you are doing is identify the sensible heat and the latent heat. Sensible heat is that heat that affects directly to the temperature of your space. For example, lining is something that affects directly to the temperature of your space. The sun radiation that heat directly to your structure affect directly to the temperature. But we also have to identify the latent heat. The latent heat is that one that affects directly the humidity of your space. So in order to select equipment that face successfully the humidity that will be created by different equipment, mostly of this heat is created through the vapor. You have to select the miscellaneous loads. In this case, if you check this information of this list, we have a list of all appliances or some appliances that can create a sensible, that can create latent heat on your system. Coffee brewer, egg boiler, warmer, food warmer. Mostly of these things are related to the kitchen or maybe water heater, everything that can create some vapor that will affect directly to the latent heat. So in this case, we have coffee brewer, half gallon. We have here sensible heat, latent heat. We have 1120. So we have to change this. BTU hours. That is our number. If you have more, let's check here, because if you have more devices in the kitchen, you have to sum or make a list of all these devices and check the table I showed you before. On the kitchen, we are not going to add the kitchen to our miscellaneous loads because we are going to design an exhaust hood here. So that exhaust hood will take care of all the vapor that is created here. So we don't need to add that load to this number. So far I'm only taking count the coffee brewer, and that will give us 1120 BTU hours. Walls, basically you need to know the configuration of the walls, external walls, internal walls. So, but the most important thing right now is external loads. So we have three options: lightweight wall, medium weight walls, and heavyweight walls. In this case, we have lightweight wall. Is basically, let me show you a detail wall, the type of wall we have. We have a medium wall is like this one. We have an indoor paint. We have a drywall. We have also an airspace. This is where basically the services will be installed, like the electricity, the junction boxes, or the boxes for your thermostat. Everything will be installed in this space. After we have a concrete block, we'll have a one inch stucco, and we have the outdoor paint. This is the detail I received from the architect. So based on this, we can select any of this type of configuration. In this you can select lightweight wall, medium walls, or heavy wall. In this case, we're going to select medium wall. Sorry. And for the internal partitions, we're going to use lightweight walls. And walls colors will be light. We don't know yet, but just for the software, we need to know if it's light or dark. So light is okay. The same, we need to know the configuration of the window. In this case, this is the configuration that the architect gave us. So it is important to identify will be the configuration of your window. How many glasses, the thickness of the glass will be really important. The doors, also you need to know. You also need to know the dimension of the window, and you need to enter the numbers here, the height and width and even the thickness sometimes. So you have to identify that information. The doors, you need to know how many type of doors you have. In this case, we have two type of doors. One is it will be a crystal door, and another one will be a wooden wall. So we will have wooden wall for the offices, and the external door will be this type of crystal doors. If we check our 3D drawing, we have this type of doors for the entrance and the exit of the reception. Shades are these, basically shades are this part of the structure that will cut the sun, and we need to know the dimension of these shades. When we are deciding or we are taking account the shades, we need to know the distance from the window, the thickness. We need to know all this information that I have here in this picture. But again, we need to finish first the drawing, and then we can get this information. So far, we're going to leave this this item without the information. Roof, again, we need to ask to our client which type of roof we are going to have, and the configuration will be really important, and the resistance of that roof. In this case, we are going to have wheel up roof, R7 boards, and 8 inches lightweight concrete. We are going to have pretty much something like this type of roof in our design. Infiltrations, we're going to calculate these infiltrations with the software. So we're going to leave this item without information. Floors, we need to know the materials, but it is important to know if the floor will be above conditioned space, above unconditioned space, slab of floor on grade. So in order to identify this slab on grade is what is at the ground level. You have above grade, below grade. So in this case, we have on grade. We don't have a ground level or under our space. So we're going to select a slab floor on grade. That will be our type of floor. Walls partitions and ceiling partition on fit. Again, to fill this information, we'll need to finish first the drawing, and then we have to take some measurements in order to have an accurate information. So, well, guys, this is all for this part of the course. We already have all the information we need to finish or to start, the thermal load calculation. The only thing we need is to finish the Autocad drawing that we are going to do on the next video. So as soon as we finished the Autocad drawing, we fill in the information we need. Basically, it's the floor area, the shades, walls partition, and ceiling. And with that, we are ready to start with the thermal load calculation. So, well, guys, stay tuned. I will be uploading the next video soon. Do not forget to subscribe to my channel, because that will allow me to continue with this type of videos and sharing important information with you. So, well, guys, God bless you. Stay safe. Take care, and see you next time. Bye.